machine learning is a very important concept in which we are going to study about SVM, support vector machine. Hope this group discussion will be useful to you. And this group discussion is going to take over by third year ABA, Jayapriya, Yogeshwari, Dakshini and Gopika Sri.
A support vector machine is a powerful machine learning algorithm widely used for the both linear and non-linear classifications as well as the regressions and outlier detection tasks. SVM are highly adaptable, making them suitable for various applications such as text classification, image classification, spam detections, and handwriting identifications, gene expression analysis, face detections, and the anomaly detections. SVM are particularly effective because they focus on finding the maximum separating hyperplane between the different classes in the target feature, making them robust for binary and multi-classes classifications. In this outline, we will explore the SVM algorithm, its application, and how it effectively handles both linear and non-linear classifications as well as the regressions and outlier detection tasks.
Support vector machine SVM. This is supervised machine learning used for both classification and regression tasks. Why it can be applied regression problem. SVM best suited for classification tasks. The primary objective SVM algorithm is to identify optimal hyperplane in the n-dimension space that can effectively separate data points in different classes. The algorithm ensures that origin between the closest point of different classes known as support vector is minimized. The dimension of hyperplane depends on number of features. For instance, there are 2 input features. The hyperplane is simply line and there are 3 input features. Hyperplane becomes 2D plane. The number of features increases beyond that. The complexity of visualizing hyperplane also increases. The scenario hyperplane is line because we are working with 2 features, 1D and 2D. There are multiple lines hyperplane can separate the data points. The challenge is to determine best hyperplane.
How does support vector machine algorithm works? One reasonable choice for best hyperplane in a support vector machine is that one maximizes the separation margin between the 2 classes. The maximum margin hyperplane, also referred to as a hard margin, is selected based on maximizing the distance between the hyperplane and the nearest data point. So we choose the hyperplane whose distance from it to the nearest data point on each data point is maximized. If such a hyperplane exists, it is known as the maximum margin hyperplane data. So here we have the blue ball is the boundary of red points is the outer layer of blue ball. The SVM algorithm has the characteristic to ignore the outer layer and finds the best hyperplane that maximizes the margin. SVM is the robust to outer layers. So this type of data point, what SVM does it, find the maximum margin as done with the previous data sets along with that data apparently each time a point. So the margin is these types of case are called soft margin. Where there is a soft margin to the data set, the SVM tries to minimize. Say our data is shown in the figure. SVM solves this by creating a new variable using a kernel. We use a data point xi on the line and we create a new variable yi as a function of distance from origin.
Support vector terminologies. First, hyperplane. The hyperplane is the decision boundary used to separate data points of different classes in a feature space. For linear regression, this is the linear equation represented as wx plus b is equal to 0. Support vectors. Support vectors are the closest data points to the hyperplane. These points are critical in determining the hyperplane and margin in support vector machine. Margin refers to the distance between the support vector and the hyperplane. The primary goal of the SVM algorithm is to maximize the margin. A wider margin typically results in better classification performance. Kernel. Kernel is a mathematical function used in SVM to map input data into a higher dimensional feature space. This allows the SVM to find hyperplane in cases where the data points are not linearly separated in the original space. Common kernel features include linear, polynomial, radial biases, function, and sigmoid. Hard margin. A hard margin refers to the maximum margin hyperplane that perfectly separates the data points, different classes without any misclassification. problems. The dual problem in SVM involves solving the large space multipliers associated with the